Hey guys, and welcome to this edition of Scruff's Garage. So if you are getting ready to install some max jacks, probably the most intimidating part of the process is drilling and setting the concrete anchors. It's really where the most risk is, because if you get that wrong, you can really mess up the concrete, or of course you could end up with failure from the lift itself. So that's what this video is about, drilling and setting your concrete anchors. So for drilling the holes, you'll need a rotary hammer, like a hammer drill. I ended up buying one from Harbor Freight. This is the Bauer 10 amp rotary hammer. I think I paid $70. It was on sale. That was essentially the same price as renting one from a tool rental place. So in this case, I got to own the tool and take my time. 5-star review on this thing. It did a great job. You also need a concrete bit, a 7/8 concrete bit. I spent a little extra on this one. This is from Diablo. I think they call it their Rebar Demon. One of the challenges with concrete bits is if you hit a piece of rebar, or like my concrete, for example, has the wire mesh, that can damage the bit or be very difficult to drill through. What's different about this bit is that it has 4 carbide cutters, so if you do hit a piece of rebar or wire mesh, it does a better job at cutting through it. So I think I spent like $35 on this. Again, 5-star review. This was money well spent. Between this and the bit, my concrete was exactly 20 years old, so it's very hard concrete, fully aged, that sort of thing, and it ate through it like a hot knife through butter. I was really impressed with this bit and the rotary hammer. Okay, let's talk about the hole that you need to drill. So you can see I've already drilled mine and set some of the anchors as well. But here's your concrete anchor. So you have a sacrificial bolt. You screw that all the way in. Then you have a nut here, and you set the distance from the nut to the top of the anchor at 5/8 of an inch. And don't cheat that dimension, because the way this works, you'll hold the top of the bolt and turn the nut downward. And as you do so, it's pulling up the wedge piece of the concrete anchor and driving the anchor into the concrete. So as you pull up, so you need some space to be able to pull up. You can see some of these kind of bit at different levels. So don't cheat that dimension thinking, oh, well, I want it flush, so I'll start it flush. You're going to run into a problem. So definitely use their recommended 5/8 depth. So what that means, let's see if I can hold this where you can see it. So the length here then is just over 4.5 inches. They recommend in their instructions to drill the hole at least 5 inches deep. So that gives you a little space. You can see mine's just a hair over 5 inches. That way, if there's any debris or anything down in there that for whatever reason you weren't able to get out, this doesn't bottom out before you get the full depth when you hammer this thing in. Now, when you drill that hole, there's a lot of concrete dust. I would recommend, so I had my shop vac sitting here beside it as I drilled the hole. I'll also mention that I used the column. I had the column sitting here in place and used that to line up my hole. So keep in mind that 5 inches is from the top of the concrete, but if you have the base plate here as well, that's another 5/8 of an inch thick. So you'll need to account for that with whatever you're using for a depth stop. I will mention the depth stop on that hammer drill is junk. So don't trust that. Put a piece of tape on your drill bit, or stop every so often and measure so that you get the appropriate 5 inches of depth. Once you've drilled, there's going to be a bunch of concrete dust still down in the hole. Don't trust Don't just go over this with a shop vac and think that you're getting all of the dust out. Especially with a blind hole, there's no airflow to draw out all the dust that's down in the bottom. So I rigged up a piece of hose on the end of my shop vac so that I could get down into the bottom of the hole. You'll also want to use some wire brushes or something to help clean out the dust that may be trapped on the walls of the hole. And then use some compressed air. So again, I held the shop vac and I fired compressed air down in here. And again, keep doing this process until you're not seeing concrete dust come back out. And shine a light down in the bottom of the hole and make sure you've gotten everything out. If not, that can impact, number one, the depth of your hole. You may not be able to get the anchor all the way down in there. Or if this is lined in dust, it may not bite very well, and that can create problems getting the anchor to set as well. For setting the concrete anchor, you have a sacrificial bolt. There's another bolt that you'll use to actually bolt down the column, but this bolt is used for setting the anchor. It's a metric class 8. So I'll call out, so in their instructions, there's some errors on this, so just be mindful of this. They say that it's a 5/8 bolt. I think they copied this from the Wedget brand, but these are not actually from Wedget. These are an M16 by 2.0. I mentioned that because that's a relevant thing. I kept damaging, well here, let me explain it this way. So as you hammer this in, they say an installation torque 90 foot-pounds on the nut or 3 installation turns. Well, that, I don't know where that came from. I called MaxJack and asked them about it. They'd never heard of that. And what I can say is that just 3 turns on this nut will not produce 90 foot-pounds. It took several more turns. I'll show you how I'm measuring that, but just be mindful, the key metric here is the 90 foot-pounds on the nut, and disregard this number of turns. That's not going to work. 90 foot-pounds on that nut is a lot, to the extent, so these are 2 of the other sacrificial bolts. They provide you 1. I've had to buy several more. These nuts are completely seized on here. It appears that it distorted the threads on the nut. It's my best guess, but I had this in the bench vise, actually both of these, and cannot get the nuts off of them. I set 2 anchors with each of these, and it damaged the nuts, and so I had to throw these are junk. So that's why it's relevant to know that this is an M16 by 2.0 bolt, and your average place like Lowe's and Home Depot don't carry that. I will give a shout out to Ace Hardware. They have a much better bolt selection, because you need not only the M16, but you also need it full thread. A lot of them will just be threaded on the bottom and up here's a shoulder, but you need to be able to use this nut as a jacking mechanism for setting the anchor. So it needs to be a full thread bolt. So not just any place has that. I went back today because I damaged a couple more of these. Like I said, this bolt is a class 8.8, which is essentially like a grade 5. I could not find where they had a class 10.9, which would sort of be the equivalent of a grade 8 bolt in SAE. But they did have a nut that was a class 10.9, and that nut, that's what this black nut is, and that seems to be of better quality than this one, which was also a class 8.8. So that's what I've had to do, and I've also rigged up some additional washers because it was deforming the washers and kind of bowing them in as you're setting the anchor and tightening this. Another challenge is how do you know that you're getting 90 foot-pounds on that nut? Because if you're just using a regular combination wrench, pulling hard on it, and I've watched some other videos, and that's how guys were setting this anchor. They were just pulling on it until they couldn't turn it anymore. but that does not necessarily get you to 90 foot-pounds. In fact, probably not even close. So what I did, I went and bought, this is a 24 millimeter or a 15/16 crow's foot on the end of my torque wrench. Keep in mind then, so even if you set this to whatever your torque spec that you want on this, you've changed the effective length. It may be 90 foot-pounds here, but then you've got an additional length here. So I'll leave a link to it. I think Tecton and probably some others had a nice little calculator on their website so that you could figure out what the difference in the applied torque was based on the length of your crow's foot. So for my setup here, to achieve 90 foot-pounds here, I've set my torque wrench to 80 foot-pounds, or like 81, something like that, because you've got some additional length on the torque wrench, so it changes the applied torque there. So be mindful of that. I'll demonstrate setting one of these for you, but just know that's how I'm setting it and making sure I'm achieving 90 foot-pounds to make sure that that anchor is truly set and is not going to pull itself out of the hole that you've drilled. Obviously your garage is going to be different, but I'll just note that my garage is built on a monolithic slab. So if you notice, there's not a concrete, a brick foundation over here with a concrete footer underneath of it. Instead, the concrete is poured thicker. It's something like 20 inches thick over here, and that becomes the footer that supports the load-bearing wall. So it's, I don't know, 20 inches thick out to somewhere in this area. I think it was like 16 inches. I have to go back and look at the drawing. And then it tapers upward to a nominal, it's probably a nominal 4 inches. So if you look at the center of the garage, the holes that I drilled there were between 4 and 4 3/4 inches thick. So those went all the way through, and you hit the gravel that's underneath the slab. But over here, because the concrete is so much thicker, these are blind holes. They don't go all the way through. It's interesting, I had assumed that in setting these, that they would bite sooner. I have no real reason for that, but that was just sort of my assumption that these would bite sooner. But actually the ones in the middle of the garage, the anchors seem to bite a little bit sooner, and there's actually a little bit more of a gap from the top of the concrete to the top of the anchor. This one in particular came very close. It had me nervous that it was going to pull out and breach the surface of the concrete, which then would be a problem. This one's maybe a 1/16 of an inch or so under the surface of the concrete. But just as a reference, and my concrete, according to the drawings that I got from the previous owner, this is fibercrete, so it has the little fiberglass hairs in it, and it has a wire mesh as well. It doesn't have full rebar, but it has the wire mesh, which would be fairly common for most garages. Okay, I'm going to install one of the anchors and let you just kind of watch the process. I'll probably play this in fast forward because this is a little bit time consuming of a process, but just so you can see what it takes. I start with the torque wrench set at like 50 foot-pounds and then work my way up. That way if it's not biting like that, the way that I want, at least have an idea of what level it was failing at. That was 50, I'll step it up to 60. So that anchor is set. I got to the 90 foot-pounds. And as you can see, this one came fairly close. It's maybe a 1/16 or so below the surface of the concrete. Always makes me nervous, but it got to the required foot-pounds without bottoming out against the bottom of your washer. That would be problematic. Okay, there you go. So those are just some tips. Hopefully they help you if you're drilling and setting concrete anchors for your new max jacks. Hopefully that answers a few questions. If there's something I didn't talk about and you have a question about, feel free to post it in the comments below. I'll answer anything that I'm capable of answering. As always, thanks for tuning in to this edition of Scruff's Garage. I'll see you next time.